Okay, so this is problem 1.4.89, and it's got a bunch of stuff here that you probably can't see in the video, so I'll read it to you, and really we're just working with an equation, but let me read it to you. So it says the distance to the surface of the water in a well can sometimes be found by dropping an object into the well and measuring the time elapsed until a sound is heard. If t1 is the time in seconds it takes for the object to strike the water, then t1 obeys, and they give an equation. and then if t2 is the amount of time that it takes for the sound to come back and impact your ears, then they give an equation for t2. And so the total time, and this is what we're concerned with, the total time, which is t1 plus t2, for the sound to go, for the object to be dropped and then the sound to come back up to the ears, is given by this. You would add the t1 and the t2, excuse me, and it's equal to the square root of s over 4 plus s over 1100. Okay, and this right here is representing total elapsed time. Okay. All right, so the question that they're asking us is they want us to find the distance to the water surface if the total elapsed time is 10 seconds. Okay, so they're actually telling us that we're going to substitute in 10 for both of these variables together. So it would just be 10, because the total time is 10, equal to the square root of s over 4 plus s over 1100. Okay, and then you're just solving from there. And in this particular section, they're teaching about substitution and how to do a U substitution. So I'll do this problem via substitution. The first thing that we need to do, though, before we do a U substitution, is get this into a quadratic form. And so what I want to do is I actually want to clear the fractions first, because I think that will be the easiest. So I'm going to multiply both sides by 4400. 4400 is the common denominator here. Okay, and that's going to give me 44,000 equals the 4400 times square root of s over 4, the 4 and the 4400, 4 will go in there 1100 times. So I'll have 1100 times the square root of s, and then 1100 goes into 4400 4 times, so I'll have plus 4s there. So effectively I'm just distributing the 4400 and canceling that with the denominators, and that's clearing the fraction for me there. Okay, so now what I want to do is write this in quadratic form. So I'm going to go ahead and subtract the 44,000 and move it to this side. And I'm going to rewrite it in descending order as well. So this is 4s plus 1100 square root of s, and then minus the 44,000, and that's equal to 0. Okay, so then we're going to use a U substitution here, and typically when you're doing a U substitution, you're letting U equal this middle term, or the variable in the middle term, and that's because generally if it fits a quadratic form, this is going to be the square of that. So, so what I'm going to do here is I'm going to say let's let U equal the square root of s, and if that's the case, then U squared would equal s. Okay, and then our equation becomes 4u squared plus 1100u minus the 44,000 equal to 0, and that's just a quadratic that we can now solve by using the quadratic formula. Okay, so when I use the quadratic formula, this is going to be u is equal to a negative b, so that's a negative 1100, plus or minus the square root of b squared minus 4 times a times c all over 2a. And that's recalling that a is the coefficient of your squared, b is the coefficient of your to the first power term, and c is your constant. Okay. All right, so if I just simplify here, this is negative 1100 plus or minus the square root of 121, let's see, it's going to be 4 zeros there. So that's 1,210,000. And then here, this is going to be, you have a negative and a negative, so it's going to be positive. And when you multiply the 4, and the 44,000, you're going to get 70,400. Okay, big numbers, but we can use our calculator. So, okay, and then we have u is equal to negative 1100 plus or minus. If I add these two together, I get 1,914,000. That's all over 8. And then if I take the square root of this number, and I think I'll go ahead and show this to you because we probably want to leave this in our calculator. The MyMathLab program can be a little bit picky about how it accepts decimals, and it did say in the problem to round to the nearest hundredth, but that doesn't mean round to the nearest hundredth while you're doing approximations earlier in the problem. It actually means round to the nearest hundredth for your answer. So everything else they want you to actually keep in the full decimal form for it. I don't know if you can see that. Let's see if you can see this. Nope, can't see that either. Okay, well, anyways, all I'm doing is I'm plugging in the 1,900,000 number, and I'm taking the square root, and I get 1,383.473888. And so I'm actually going to leave that in my calculator because I want the whole decimal portion of this. So this is plus or minus 1383. Okay. Now from here, there's two things going on. You have a negative 1100 minus this number, and you have a negative 11 plus this number. Negative 1100 minus the number will result in a negative answer, and that's not going to make any sense because we're talking about the distance down to the water's surface, and negative distance just doesn't make any sense. So I'm not even going to worry about that option. I'm going to go ahead and do this, negative 1100 plus the 1383.473888, and then I'm going to divide by 8. Okay. So I'm just going to subtract 1100 and divide by 8, and I'm going to get so I'm going to get u is equal to 35.43423606. Okay, now we were looking for s though, and not u. And if you recall, up here we had gone ahead and defined that s was going to be equivalent to u squared. Okay, so what I would need to do then to find s, since s is equal to u squared, I would need to square this number. Okay, so I'll just do that, and the number that I get is 1,255.59, and the units that we're talking about here are feet. Okay, and then you also want to ask yourself if that's a reasonable answer, and for a well, that is a reasonable answer for a water level. And that's it for this problem.